So I want to end this sequence of lessons with a case study on a made-up language that I invented called the LAL-digit language. Right? And this is a regular definition, right? So we are defining certain terms or regular expressions based on some extended regular expression syntax, right? So what we're saying a digit is a digit can be any character 0 through 9. What we're saying in out louds is we're defining in out louds to be any character O or L in either order, right? Just a single of those characters. Then we're defining the LOL regular expression to be the character L concatenated with the character O concatenated with the character L, right? So LOL, each one followed by the former. And then we're also concatenating on out louds, but 0 or more repetitions, right? So LOL would match with 0 repetitions, but so would LOL, LLL, right? Or LOLOLOL, or LOLLOLOL, right? So this is a pretty funny little language. And our last regular definition term down here is our tokens. And so a token is going to be either an LOL, right? So either this definition, it will match against that, or it will match against a single digit. And we will yield two kinds of tokens. We'll yield an LOL token or a digit token, right? So we're going to go actually implement this little LAL digit language in a tokenizing form such that we can process some input strings and get some output of what are the tokens that made up that string, right? So remember, a tokenizer is going to scan an input string to find lexemes in it and yield tokens. And before we jump into today's code for this and walk through it, just a couple of quick notes to understand going in. So first, we know that we're going to start at the very beginning and work our way through it. We're never going to move backwards, right? We're never going to need to backtrack from where we've gone. We're going to do this by only moving forward one step at a time, one character at a time. But one of the things we're going to do to simplify our implementation is give us the ability to peek forward by one character, right? So we're going to be able to look ahead by one character and see what is the next thing that I would take if I were trying to process this string and find lexemes in it. The reason why we want to be able to peek ahead is we kind of need to know, hey, what is the next lexeme I'm about to begin, right? So if we looked at this example, we would know that if we saw an L, if we peeked ahead and we saw an L, we would know that we're about to process an LOL, and we could go run some code to take those characters. But if we saw a digit, we would probably want to go in a different direction in our code to try and pull out a digit token, right? And if we saw something else, we're going to have to handle errors that don't conform to this language as well, right? So it's really helpful in such a common need when you're trying to tokenize your input string to be able to peek ahead by one. And this leads to design decisions that people see in other languages in the real world as well, right? So when you have variable names in programming languages, they tend to have to start with a letter or a specific other character like an underscore or something that's not a number specifically. Most programming languages, you are not allowed to begin a variable name with a number. And part of the reason for that is because the programming language parser is going to have to go through and find the tokens of your code. And it's much easier to separate out, well, looks like it's about to be a variable name or some keyword versus a number based on just looking ahead by one character and seeing whether or not it's going to be a token of one type or another. And if we didn't know, or this also allows us to know when we've reached the end of a lexeme, right? So with our case study here, how do we know when we've reached the end of this LOL regular expression? Well, when we can't take some, or when we get to something that is either not an O or an L, that means that we've reached the end of that lexeme and we should begin after that focusing what is the next lexeme, right? So if we have, for a quick example here, LOLL2, right? We take this character, I didn't mean to delete that, LOLL2. We take the first L, we take the second O, we take the third L, we take the fourth character here, which is another L. And we need to be able to peek ahead and say, okay, well, before I take the next character and I process it, am I still working on the current token, right? Am I still working on the current lexeme? And no, if we see a 2 there, that means, okay, we're done. This would be an LOL token whose value is LOLL, right? And then this next, we could begin a different token, which would be a digit token and just the value 2, all right? So this is a very simple little language that we're trying to tokenize here. But let's actually take a look at some code to bring this to life. Right? So before we dive into the code, let's demo the output so we understand what's going on. Right? So today's lecture materials are in the lecture directory and then lecture 18-lexical. If you pull today's materials, you'll see that. And then if we go ahead and make today's little example, we're working in a file named tokens.c, and that produces a binary named laldigit. So I'm going to run the laldigit program just to get a sense of what we can do with it. And all it's doing is waiting for some input. So if I tried, for example, LOL and press enter, we see that it's outputting the token. This is a token type LOL, and then the contents of that token that matched are what follows, right? So if I did a more complex LOL, something like this, notice that's still a single token, and it's a much longer one because we were matching 0 or 1, or 0 or more O's or L's after the initial LOL, right? If I tried just LO, we would see that there's an error, like that didn't actually complete an LOL. Remember, the definition, which I can switch back to, was L followed by O followed by L, and then any number of O's or L's after it, right? So that didn't work. We could also try a single digit, like 1. We could try multiple digits one after another. And notice that we're getting many tokens in this input because our language doesn't have the idea of a number expressed in it, like a whole number that would consume all of these digits together. We're saying this is a very simple and naive little language that an individual digit is only one of 0 through 9, and that's all we can really do with our tokens, right? We can have these back to back, like LOL 4, LOL 20, LOL, OLOL, 211, right? And notice that the tokenizer is separating all of these lexemes out from one another. So we've got LOL digit 4, and notice once again, only single digits are being pulled out as our tokens there, but this longer match for LOLOL, it consumed that entire token just fine, all right? And of course, if we just type gibberish, we get lots of error tokens because it doesn't conform to our language. So I'm going to press Control D to end my input, and let's go take a look at tokens.c. All right, so this is a fully working example that I'm going to encourage you to read through and take some time trying to understand. But I want to give you a high-level walkthrough, and then there will be some details I'll leave to you to think through and how this all comes together and some of the specific details. So we're not going to do dynamic strings like we're doing in our shell that we're building up to in your current lab. We've got a fixed length buffer. If we overran this, we'd be in trouble. So we're just going to call it naive. Our buffer is a maximum of 124 characters for a given line. Where we've got some function declarations that occur at the top of our file. And these are just going to be the helpers that we need in order to implement this simple little program. So this first one is reading a line into our buffer, right? So that shouldn't be at all a surprise. This next one I want to talk about briefly. So what we're going to do here is have a notion of a character iterator. And hopefully from Comp 401, you remember the concept of an iterator. It allows you to traverse some data structure in some specific order, right? And so we're going to sort of wave our hands, and we're actually doing something kind of tricky here. We're saying character iterator isn't actually anything new. It's just a pointer. And this is a common strategy in C. To say that, hey, a pointer to something that's pointing into an array, we can treat that as an iterator with very little implementation overhead in doing so, right? Because if we have our array and we have a pointer to some item, right? If we wanted to iterate to the next item, we just add 1 to that pointer or increment that pointer by 1 memory address of the correct offset size. And so we can very easily iterate through some address space in memory if it's contiguous and shaped like in an array. And of course, in this case, we're traversing just an input string of characters, right? So on the next few lines, these are some helper functions for dealing with that iterator. And these should feel pretty familiar coming from Java. We've got the ability to ask an iterator, right? So an iterator, do you have another item or have we reached the end? So before we take the next thing, we can always ask, is there something else for us to take? We can peek ahead. We can say, hey, if I were to take something right now, what would I get next? But we're not going to update that iterator. Lastly, we can ask the iterator for the next character, and the next character will move the iterator forward, right? So if the iterator is previously pointing to this element of my array, it's going to be pointing to the next element of my array after that, and it will return to me what it was previously pointing to, that character value, right? So these are some of the helper functions that we're seeing. And then if we scroll down just a little bit, we'll notice some of the makeup of our token. The first thing that we see here is our enum for token types. So we've got 3 types of tokens in this simple example. We've got an error type, a digit type, and an LOL type, right? And we're just declaring this as a token type, type def, so that we don't have to say enum token type anywhere we want to use this, right? So token type is now going to refer to any of these 3 possible values. And we're going to also have the notion of a slice that I'm going to come back to in just a second, right? So let's talk about what a token is. So we're trying to extract or emit tokens from scanning through our input string. And notice a token is made up of 2 things. It's made up of a type, which has to be error, digit, or LOL, and then a location, right? So let's talk about what a slice location is. So what we're going to see is, let's imagine our input is LOL and then the number 2, right? So if we're talking about the token that is going to be of type LOL, what is its location going to be? What is the slice going to be? Well, its start is going to be the memory address that it began at, right? So let's imagine this is OXA, OXB, C, and D, right? All right, so its start, if we imagined what is the slice of its location going to be? Its location, so the slice S, we would initialize with a location of OXA, right? But that's actually just going to be the address of our cursor or our pointer to that. And then the length of this is going to be 3, right? So the length field of our slice is going to be 3. So what is a slice? It's a pointer to the start of some string, right? So it would be a pointer to the start of this token's location in the input string, and then some length that tells us the span in which that particular token occurred, right? Similarly, if we were talking about this number lexeme 2, it would be starting at the address OXD and it would have a length of 1, right? So what we're seeing here is slice gives us a way of referencing subspans of a given much longer array, right? So with a slice, we can say the start of some slice of this string is here and it has a length of 3 characters. And we can do that without having to duplicate that data out or copy that character, those character values somewhere else, right? So we're setting up references to ranges of our input string. That's what's going on there. Next, we're going to see that there are 3 helper functions for taking specific tokens. So we need to a subroutine for taking an LOL token or a digit token, or if we reach an error, we see that we've encountered a character other than an L or a digit. We know that we need to take an error there. And lastly, there's a function to print out a token once we've extracted it from our input string. So our main function is just going to loop through lines. We're reading lines, we're waiting for user input. And what we're saying here is set up an iterator to the start of our buffer, right? So we're setting up an iterator at the very start of our string after reading the next line in. And here's where we're using those iterator functions, right? We're saying while there is something for us to read next, so while there is a next character for us to read, we're going to peek at that character, right? We don't want to take it yet. We're not yet sure where we want to go with this character. So we're going to peek it first and store it in a character named C. We're going to set up some space for the token that we are extracting or trying to emit from this next range of our input string that we're scanning. And we reach a switch statement. And so here, notice this is a translation of the regular expression that is the character range, right? So this is 0 through 9. Oops. This is 0 through 9 expressed as a switch case statement, right? So case 0 or case 1 or case 2 or case 3 or 4 or 5 or 6 or 7 or 8 or 9. This is where in our language we're specifying, okay, if we see this character, then what we're going to do is we're going to assign to our token the result of taking a digit from our iterator, right? Notice we're passing a reference or a pointer to our iterator such that the take digit can modify that iterator's contents. And we'll look at that in just a moment, right? Whereas if we see an L in our input, that means we're at the start of an LOL token, and we should go take that LOL token, and we're going to jump to its subroutine to do that. And if we see something that's not a digit or an L, based on the language or the grammar that we've specified, it means that we've got some kind of error in our program. So we should probably take an error and move on to the next thing. Right. So if I jump down to the take digit implementation, we are going to see that we have a pretty simple implementation here, right? So we're passing a pointer to a character iterator. And that's actually a pointer to a character, right? Because a char iterator is a pointer. And the reason why we need this is we need to be able to advance this pointer by 1, right? So we set up our location, which is the current address pointed to by our iterator, right? This is where we were currently looking at in our input string. And the length of a digit token is always 1, right? We're always taking only 1 digit at a time. We'd have to do something more complex here if we wanted to take whole numbers. Then we're saying move the iterator forward, take the next character. We don't need to actually do anything with its return value because here we are, remember our slice is keeping track of a reference to our input string. We're not needing to copy this anywhere. So we're just moving our iterator forward by 1. And then we're setting up our token. We're saying this is the type of the token that we're about to return to you is a digit type token. And the location of that token is where we were pointing to when we reached this subroutine, where our iterator was, and its length was 1. And so that's what we return, right? If we look at the take error, it's very similar, right? We're only taking 1 error character at a time. We could imagine a more sophisticated error handler here that maybe took all of the characters that weren't a number or an L until we reach the next one that might be valid. But here, just taking 1 character at a time and saying, hey, there's an error, that's totally fine for this simple little demo. The last example of a function that's taking one of these tokens and processing it is the LOL example. And this one's a little bit more sophisticated. I'm not going to talk through this in its entirety quite yet because there will be some questions about that in the Gradescope homework on this particular video, right? So this is a function that's a little bit longer because it's needing to scan through and figure out, well, how am I a valid LOL token, first of all? And second of all, when have I reached the end, right? So there will be some questions about this, but overall, this is an example of a very simple little tokenizer that is taking an input string and trying to convert what was originally expressed as a grammar in regular definitions and turn these regular definitions into our tokens, right? And we'll be needing to do this when we go to implement a shell. We'll need to have a grammar for our shell's tokens and implement something very much like this example file that we're seeing here. The same process is at play anytime you're writing a programming language or an interpreter for trying to pull out the important pieces of text from the lexeme definitions. So here, these are our lexeme definitions, and this will yield to us tokens that we can then use in our program to interpret the meaning of, and then go act on or compile a program from, so on and so forth.